Assalamu alaikum. Hello everybody, thanks for joining in. My name is Ghaith and today I will guide you through our project proposal for pothole severity classification using computer vision. So we have identified three main objectives that we want to pursue in this proposal, and they are the following. The first one is that we want to develop a deep learning model that is capable of detecting potholes, objectives, and edges with high accuracy. The second thing is that we want to utilize DeepSORT to track individual potholes. So when we track them, we can get the best frame we want to better estimate the depth. And the third thing is to implement a complementing system for evaluating the severity of each pothole that we track. So we have segmented our project into 4 stages. The first one is where we pre-process the data. The second one is where we detect the potholes. The third one is where we detect the edges. And the fourth one is where we estimate the depth. So first, for pre-processing, we used an instance of Label Studio to label the potholes in the dataset given to us at the beginning of the hackathon. We used this labeled dataset to train our model and increase our accuracy, as well as we can get a better understanding of the different pothole types that we have in this dataset. In addition to labeling, we also augmented the data given to us. So we cropped the images, we increased the contrast, we also rotated them to get a bigger data set to train our model. We've also segmented the video given to us. So when the video is MP4, we can turn it into segments of frames, and throughout these frames, we can individually see the images and process them. So this is an example of a pothole object that was detected by our model, and our model was trained in our augmented dataset. So on the right, we can see an example of an output image from the first stage of pothole detection. The pothole was tracked using DeepSORT to rank the quality of each frame. And then we passed the highest quality frame to the edge detection stage so we can create a mask of the pothole. In the edge detection stage, we manipulate the image properties to extract the pothole dimensions from the street. So in the edge detection stage, we have the original image and we split it into 3 channels: the hue, the saturation, and the value. And we have found out that the hue layer gives us the most information about the intensity of the pixels of the images, so we can use that feature to identify the pothole from the street itself. So we extract the hue layer, and then we apply a blur to it to smooth it out and remove the noise. After that, we turn the grayscale image into black and white using binarization, because we want to split the image into the street and the pothole object. And then we smooth it out again to remove some noise. And then we use the canny edge detection technique to detect the edges of the pothole. And then we take the max island, because that is the relevant island and the one that represents the pothole itself. And then we can see a result, which is a mask that is pretty well over the pothole. So using the masks that we got from the edge detection stage, we could put it on top of the image, and we can use a heat map to understand the depth of the pothole. And using that depth, we can calculate a volume for the pothole. And from that volume, we can say how severe this pothole really is. So from the depth heat map constructed using the mask that we got from the edge detection stage, we can actually construct a 3D model of the 2D image of the pothole. And we can understand the different depths that this pothole has to better estimate its volume. And then after we collected all of the volumes of the different potholes that we identified in the video, we can normalize the population of the volume so we can rank them. Which one was a low severity pothole, which one was a medium severity pothole, and which one was a high severity pothole. We ran our program in 13 seconds of the video given to us by the competition. And we can see an example output of our program. It gave us really important information, such as the timestamp of when did the pothole appear, as well as an image of the frame of the pothole, as well as severity of the pothole itself. So this diagram shows us a summary of the architecture we used to tackle this problem. Here above, we can see the first stage, where we detected the pothole and tracked it down. Afterwards, we picked the best frame to see the pothole, and we passed it to the edge detection stage. In the edge detection stage, we created a mask that goes over the pothole. This mask is then applied on the heat map generated from the depth estimation stage, and combined from these two stages, we will have an estimation of the severity of the pothole based on its volume. So thank you for your time. We had a lot of fun working on this project, and we're excited to see the results. Thank you and have a good day.